Today we are going to learn how to integrate some functions that you don't yet know how to integrate because you can't anti-derive them. But today you will be able to, and it is called the substitution rule for integrals. So, the substitution rule needs you to identify what function is the inner function, kind of like a composite. So, if you can identify the inner function, you'll be good to go. Let me show you how it works. If you look at the integral of x cubed cosine of x squared plus 4, our inner function is x to the fourth plus 2, which means I'm going to make that u. But before I can integrate a u, I have to have a du at the end. I can't integrate u in terms of x. So, we derive the u to get 4x cubed, and that means that du equals 4 times x cubed dx, or that dx equals du divided by 4x cubed. So I'm going to go ahead and substitute that in for my dx. My x cubes cancel, which is nice. I can pull my 1/4 out front, and I have 1/4 the integral of cosine u du. Because I have a u and a du, I can now antiderive that cosine, and the antiderivative of cosine is sine. We need our plus c, but we can't stop there because we can't leave a u in our answer. So our answer is really 1/4 sine of x to the fourth plus 2 plus c. Try another one. If you look at this one, our inner function is going to be 2x plus 1. du dx will be 2, and du divided by 2 will equal dx. And I took a step out there. If you need to pause and do it the long way, go for it. So, I've got the integral of radical u, and then dx is du over 2. So I'm going to make this 1/2 times the integral of u to the 1/2 du. Antiderive, add 1, divide, so we get 2/3 u to the 3/2 plus c, or 1/3 2x plus 1 to the 3/2 plus c as our final answer. Let's try another one. This one, our u, not our du, our u is probably going to be 1 minus 4x squared, because the derivative of 1 minus 4x squared will have an x that might cancel with that x at the top. Let's find out. So du dx is negative 8x, so du over negative 8x equals dx, and I can substitute that in. Notice here my x's will cancel. I can move my negative 1/8 out front. And my 1 over radical u is u to the negative 1/2 du. Antiderive, u to the negative 1/2 becomes 2u to the 1/2 plus c, which becomes negative 1/4, 1 minus 4x squared to the 1/2 plus c. Now, for the next example, let's give it a try. Your u is probably going to be 1 plus x squared, which means du dx is going to be 2x, and du divided by 2x will be dx, and we end up with radical u, x to the fifth, and dx is equal to du over 2x, and we find out that one of these x's will cancel with that x. I can move my 1/2 out front. The integral of u to the 1/2 times x to the fourth du. Well, we're doing all right, except that x to the fourth is still there. we have to be entirely in terms of u if we have a du so that we can antiderive. So, let's think about this. If u equals 1 plus x squared, u minus 1 equals x squared, how do I get a u to the 4th? Or an x to the 4th? Well, if I square both sides, then u minus 1 squared will equal x to the 4th. And I can substitute that in. So we've got u to the 1/2 times u minus 1 squared du, or u to the 1/2 times u squared minus 2u plus 1 du. Simplify it a little more, we get u to the 5/2 minus 2u to the 3/2 plus u to the 1/2 du. Antiderive, we get 1/2 times 2/7 u to the 7/2 minus 2 times 2/5 u to the 5/2 plus 2/3 u to the 3/2 plus c. Now, we simplify this, we get 1/7 to the 7/2. Here we get minus 2/5 u to the 5/2 plus 1/3 u to the 3/2 plus c, and our 1 plus x squared was our u, so we can put those in. And that's how we end up with our final answer. If you have questions about this, see me tomorrow. This last example I'm going to show you in person, because it takes a little bit of explaining, so we'll do that first thing tomorrow.